let's look at entities, attributes, and entity sets. Okay, how do you define the relationships in entity relationship diagram representation? Okay, so an entity is represented with a square, so that could be, say, an employee. Okay, it can have its attributes. Name or whatever, salary or something. Okay, there could be another entity here and it will have its own attributes. Okay, the way the book shows is it has a department ID. So the primary key is always underlined in this. And these two entities are then related through a relation which is represented in a diamond, with a diamond. So you can think of this as works in or some kind of a relationship. Okay, so this is the basic, most important representation that you have for entity relationship diagrams. Okay, now you can have, so this is now a relationship in which this entity, this relation is joining two entities. Okay, now this relation itself can have its own attribute. Okay, something like since. Okay, so this person has been working in this department since. So if we think of the other defining term is, what is the degree of this relation? So because it is joining two entities, it is a binary and degree is 2.
On the since, you can see how these other attributes easily map to being columns in tables. Where would what would be the case in terms of since?
So now this relation itself is also a table, and this one of the columns is going to be since. So this is, and what
it's always going to be a separate table?
Yeah. You can actually, so not always. Now let me just rephrase that, because you can actually move the attributes here into something else depending on what kind of relationship you have.
Since could be stored in employee.
Absolutely. Depending on, so it is again, depending on the type of constraints you have, you may be able to move an attribute around or whichever way it is. Okay. But this will be a table. Okay. So if this was something like we have another one, department, say company 2 or something, some other entity that this relation joins, so then it will become ternary or 3. Okay, so this is the whole concept of entity relationship diagrams. Okay, representing the relations and attributes and entities in a pictorial format. Okay, so you can think of it more clearly. Okay, so now the term value set for, so this is now an entity, and a group of entities, similar entities, is called an entity set. Okay, so if you think of an employee entity set here, say let's put it here, and then you will have E1, E2, E3 are the instances here. Okay, but because they all have the same attributes, they can be grouped together to actually make an entity set. Okay, so each employee becomes an instance of this entity set. Okay, let's see what was the other one that I looked at. Okay. So next is what kind of constraints make up a relationship. So there is one is cardinality ratio, is that you can have an employee working in one department or a manager. So you can have say a manager can actually have multiple departments than he could manage, right? So this would have 1 to n cardinality, but you could have, if you go say a department and an employee, say, so let us go back and say an employee, instead of manager, let's make it employee, is working in this department, and here you can have then employees here, right? So this would give you a different cardinality. Or you could have, so you could have cardinalities of the form like 1 to n, n to m to n, where you totally open it up, like a manager can do as many departments he wants to do, and each department can have as many managers. So you can have, or you could have 1 to 1. One manager can only do one department, and a department can also have something like this. So second is participation, that defines. So this is one attribute, is actually the cardinality of the relation. Second is, take an example of, the book gives an example of insurance policy, or let us think of an example of, yeah, that is actually a good example. We'll stick to that. And so there is, say, an employee. There is a company here. I'll draw it like this. I'll just erase this one and give you the whole thing again. Again, our employee, but now this relation is, say, insurance policy. Okay, and then there are dependents who can benefit from this insurance policy. Okay, now what is going to happen is that these dependents can have their, say, names. Where is the name here? And say age, that is the example that book takes. And here is the cost. Okay, and here is SSN policy. So now what is going to happen is, till there is an employee working in some department here. So we have our tree on this side. If there is no employee, then this can't exist, right? So this is a constraint, existential constraint. Okay? So now what you are seeing is that this, so if we say, so you can call it as total dependency or existential dependency. Okay? Then what you see, the next thing that we see here is, now this entity, the dependents, can they be identified? What I'm trying to think is, will that be, so when we are identifying, okay, yes. So now this person, this dependent's name has to be combined with the primary key of this employee for it to be unique, right? Because they could have twins with same name, same age, but different names. I mean, hopefully they'll change the names at least. So in that case, what happens is, so what you do is, now this is becoming a partial key, because without this SSN primary key of the employee, this guy can't be uniquely identified. Okay? So a partial key is represented with a dotted line underneath. Okay?
Doesn't seem to make much sense, the concept of a partial key.
Why?
I don't know. I mean, the point of the key is that it opens something, or it provides a function. I don't know. I'm just.
Oh, okay. The term doesn't make sense, or?
I don't know. I mean, you can see what a primary key is. You can see what a foreign key is. I don't really understand what a partial key is.
It's a kind of way of saying if you were to put a primary key in this table, the primary key would be on the employee ID
and the.
Does that make sense?
Think of it as a composite.
You wouldn't find one in isolation.
Right, but this is a way of kind of showing attributes and their relations. It's not,
Okay.
It's just a different kind of schema.
Right.
So it's like the SSN would be a partial key with respect to the dependent, right? I mean, the union of the SSN and the name is the primary key for the...
The composite key of the two is actually the primary key for,
Right.
with respect to the kid.
Right. There's a key
Is
for
that-
the parts, and that's one part. Right.
Yeah.
Is that okay? The other, so this is how you can represent entities where there is existential dependency on something else. Okay. One more thing that you have to look at is actually a relationship called is a relationship. So it is, what is the spelling of HIE, hierarchical?
Yes.
Is that correct? Oh. Okay. Hierarchical relationship, and in this, if Alex was not taping, I would tell something, but I can't. No, that's fine.
You wouldn't believe what's gone on camera this year.
Okay. So is a relationship can be, so let us think of it. It is by itself quite explanatory, but let us think of it as when you say A is a type B, type A is a type B, that means you end up encapsulating at least one of the two into the other one. Right? It is almost, it becomes, is an instance of, I mean, by talking about it. So what you can think of is that, say we had that employee, so it gives you two examples. Let me just write the one that is with the employee. It has its own attributes, and then let's define.
This notation with the boxes and triangles and circles
Are standard.
Does it correspond in any meaningful way to how those terms are used in normal flowcharts? In terms of branching?
I'm sorry, I can't answer that. I can check it, but has anybody here used normal flowchart? I have never actually used flowcharts.
Yeah.
Is it same?
It doesn't look to be the same with the diangles.
Like from Visio or something? Is that what
Yeah.
you're talking about?
Yeah. I mean, diamonds normally represent decision points, but you've had a diamond there linking.
Yeah, that's the
There's
relation.
no conditionality in it. A diamond normally represents conditionality, as I've seen it.
This system is in, I guess, no.
Huh?
This system is in the Z.
Okay.
ERD diagram.
So probably when you use ERD, you use Visio to make ERDs, it'll give you these choices.
It doesn't give you
So
that whole triangle, but it gives you the other one.
okay. Well, he's done so much. Great.
Hey, can you have two entities next to each other? You always need some other symbol in between.
What do you mean by that?
Like having two boxes connected without having a triangle or a diamond.
How are they then related? There has to be some. There has to be some defining part that will tell you why they are related, right? That is the whole idea about breaking down. So if that is the case, then why are they not just one table? What I'm trying to think is that, yeah, right, exactly.
Can you address at some point the difference between this and object-oriented program? You know, whether this is an identical concept? Because later in the book they're talking about some object-oriented.
Okay. Oh, that is very different.
That is very different.
Yeah. But it all depends on what you're talking about, right? So in object-oriented, what you want to do is what does object-oriented? I won't get distracted too much, but we can actually go into. There are again two parts. There is object-oriented databases, and then there is object-oriented programming is totally different.
Okay.
So the database itself enables you to define objects, but we can devote a chapter on or lecture on it that what are the recent changes that are happening we can devote some time on it. But don't get confused here.
Okay.
Yeah. This is just a basic representation of, I think just the term object is used so much is what will start making you think like that.
Right.
But what we can do is it is like either we can have a recitation on object-oriented databases. I can give you guys something to read, and we can then discuss it, a research paper on how things are being done in that.
Okay.
But
So keep this separate.
yes, this is just a very simple, and what you are seeing is that all it is doing is trying to simplify and make representation pictorial. That is all the object here is. But you want to still use certain standard notations so somebody else can understand it. That is all.
The ISA doesn't become a relation, doesn't become a table.
ISA, let us think. So what you did was you took this. I'm trying to think, how will it inherit all the attributes of, because now this employee has to inherit everything from this employee in addition to this attribute of, say, whatever is hourly wage or whatever they use. So if we do that, I'm trying to think, how will we semantically represent these tables?
Sometimes it would be done all on a big table, but with some columns that are left empty when they don't apply.
I would think something else. I would think, okay, first question is about ISA. I don't think ISA is going to be a table. Okay. But the second question is about how we'll think about it doing this. Yeah, you'll have to have a master table. How else would you do it?
Can't you just have a manager table and an employee table and just link them? Your managers and employees?
No, that is different. But this is an employee. You can say that there is a table employees where all the employees are there. Then suddenly you find that you end up hiring temporary employees. They have this extra field.
Oh, well then instead of you have a temporary employee table.
Yeah,
Wait, doesn't it depend on how many?
Would there be a design problem with having something like an employee table and then a column like employee type, and then have each employee type correspond to, like have an hourly employee type correspond to a table holding data only for hourly?
Okay, so what you do is you end up, okay, so let us think of it as a new column which will have the values corresponding to either he's a full-time or he is...
Yeah, so basically a column that
You know what?
to another table.
Maybe that is what will be an ISA table. That is an interesting thing, because that actually what it is telling you is that from this ISA table, you can actually go either to employees table, but no. How will the hourly employee inherit all the attributes?
It would just be a separate table with a foreign key tagged to the employee ID.
No, but that means, okay, so and you'll stuff
All our
everything.
employees are employees. So that means you first have to have a row in the employee table to exist before you can have a corresponding row in the hourly employee table.
And then have a foreign key referencing to, yeah. That is right.
And given that, I don't. Do these diagrams really help you? You got to set up the tables, right?
Huh?
You
Yeah.
have to set up the tables, and it seems like just as challenging to do it with or without the diagram.
In my experience, where it has helped me a lot is when, say, I am starting to work on some existing module, if I can see an ERD, rather than going into the schema and finding out what are the different tables, who's talking, it just gives a huge...
I can speak from experience on that, since Tony came up with this big complicated table set on our project. I looked at all the tables. Finally, I made my own kind of version of a thing like this with all these arrows going. Then I could understand it.
And it is easier to maintain that way. It is really easier. It is so. What you will see is that it just gives you another layer of abstraction to view it.
It's not like a one-to-one between using a table, so that's the only thing.
Well, I think that's why it's useful, actually, because the tables become so convoluted in order to engineer these relationships, and actually teasing this back out from the tables is hard.
Mm-hmm.
So it helps you to keep clear what you're trying to achieve in your table structure.
But it seems kind of to be an art then to go from this representation to the actual table.
I'll just give you one quick. It is not. I wouldn't say it hard. Or you said art?
Art.
Oh, okay. Art. Okay.
There might be many different ways to do it. It probably depends on what kind of data you're putting in the end and what kind of queries.
No, I think it doesn't change that much, except it changes as long as you know where the constraints are. If they are well defined in your ERD, you'll be very close to this implementation, because you would have thought about a lot of things while you're writing this up.
So, could we take this specific example then of the hourly employee thing? We were taught before that the question of whether you would, for example, just stick a couple of extra columns in one employee table and say hourly rate, etc., to deal with that case or not, or whether you would break it out into separate tables, simply depended
We'll come
not on optimization, on whether
on normalization.
Exactly.
That is where we will come to. We'll start talking about redundancy and.
Okay, so my question is, would you have several possible data structure implementations of one diagram like that?
Say it again.
Well, if you had
okay.
different kinds of employee and no one employee type represented more than 10% of the workforce, you would represent that in a data structure with lots of different tables.
Right.
If you had 98% the same and only 2% different, you might simply sling a couple of extra fields in one table.
Stick it in there.
Different data structures. Would those different data structures come out of this diagram? Would they be two different diagrams?
There'll be different diagrams, because what you'll have to then identify is whichever way you break it. You'll have to, because then you'll be identifying attributes related to, because there'll be a reason for you to actually break it.
Okay.
Right? So you would be able to identify.
Right. So there's a strict one-to-one relationship between a diagram and a data structure.
Once you have converged on what you, again, from the point that we had, that you could actually move something into, say, an attribute into something else, like about the manager sense or something like this. But once you have converged on it, the idea is actually it should have a direct correspondence.
So that means
every box becomes into a table, and every relation, every diamond also becomes
into a table. Yeah.
And all the attributes are columns. So if you have your diagram like that,
but I thought kind of the point was this thing that you didn't really know you didn't know to do this diagram, you didn't need to know exactly how many employees you had and how many hourly workers and so forth. But that seems to be, you're saying that's essential to know that, because the diagram will depend on that.
No, but the other thing is, okay, if you don't know, the question is whether you know it or not, don't know it before you start. Is that the...
Yeah.
So if you don't know, it is the same problem. When you are even implementing your system directly, you still maybe keep on refining it as you know things, right? But what you will do is, so I should just, maybe I have not clarified, this actually supplements all your data model. That is all it does. It is actually something that you can give it to your group mate to actually look at it and come up much more quickly or think about your data model. This will make you look at your data model in a visual perspective. Is that?
But I don't think it's true that there's only one table structure possible for anyone who's given diagrams. And I think the example that John came up with was a good one. And just looking at this thing right here, you could either put the hourly wage field, and I assume there's also a salaried field. You could just create those as two columns in the employee table and have sort of a toggle field, sort of a type field, right? Or you could put them in separate tables. Like both of those would be perfectly reasonable ways to engineer this. The decision as to which way to go is going to be something like John said, the percentage of people in one way or another.
That is true, but that exactly was right. But the thing is, if you draw your corresponding ERD in this way, then you should actually keep it consistent. If you actually show it here and you implement hourly wage here, add as a separate another column in this, then you should move this up there. That is all I meant to say. You can do the same thing in whatever optimal situation you are in, and this will change the way you said that this will go in here, but then don't keep the ERD like this. That is all. Stay consistent so somebody else can, because if I look at this ERD.
But I'm saying that, we have one employee table, right, which has three fields, a type field, and then depending on what the type selection is, either an hourly employee or salary.
Okay.
And we're going to put some sort of constraint in there, probably a check or some sort of a trigger to make sure that you can't be both. You can't both have an hourly wage and
regular employee.
Like that. So the is a relationship. The way that this thing is drawn right here is a way of saying that an employee is either an hourly employee or is a salaried employee, right? So I may implement it all in one table, but if I move that bottom information up to be, to just be sort of attribute fields coming off of employee, I lose a central part of the data logic of the application, which is that you can't be both, even though I've implemented it all in one table. So I would argue that you should keep the structure this way, even if you implement it in one table, because what you're trying to express here is a logical difference between two different types of employees.
I want to correct you on one thing. Yeah,
you don't split the employees into these.
Exactly. These are not the only two ways. Let me just answer, and it is clarification of the point you raised. One is, if you actually read the book also, whenever you talk about is a relationship, it is very subjective.
Right.
Very subjective, and it'll even point it out intuitively. Everywhere it'll say, is every employee an hourly wage? Intuitively not. Right? But it may be the case. So what I want to say is that just make sure, absolutely you can move it up, but just make sure when you implement it, if your field is actually off a part of the employee table, then show it as an attribute here. That is all. It is absolutely fine to implement in the way you find, because every situation is different, whether it is 90% in it or 10% in following this structure.
But you lose there just the logic that you can't be both hourly and salaried, which is something that's captured nicely by this notation.
Now, this diagram is an implementation diagram. This is not necessarily a logic thing. It tells you how many tables you need and what attributes you're sticking to each of the tables. So if you decide that you can be only one or the other kind of employee, you don't need that to implement the system.
You just need a Boolean.
You just need a check constraint that you can be both. That wouldn't come here. This is not indicating that you can be only an hourly employee or the other type. What it just indicates is that all hourly employees are employees. All the other subtype of employees are employees. And hence, you can reduce the amount of data storage by creating 3 tables instead of 1 table with a lot of columns.
Sure. I guess I object on principle then.
This is an implementation representation. This is not necessarily a logical representation.
But I think its value is as a logical representation. Its value is at the point of coming up with, when you're sitting down with a client and you're trying to find out from them, how should I represent people? Is an hourly employee the same as a salaried employee? Can someone be both? And they come back to you and they say, no, someone can't be both. Well, I can implement that in one table, right? But I also want to make sure that I have somewhere sketched out for myself the logic, that sort of that makes it clear where there are overlaps between sets in the database and where there aren't, right? So I think, I feel like there's a value to having all three of those boxes and this little triangle to put the thing into one.
I think what he mentioned is very important thing to take is this representation is telling you is this employee is going to inherit all these attributes and this. Okay, now how you actually include it in the table, whether you want to keep it depending again on your situation. Right. So this is giving you a very logical understanding right here. It is fundamentally it is assisting you. Okay, let us think of this as just put an hourly wage here. Okay, just this change will suddenly make you think very differently about your system. Because here you suddenly started thinking about, okay, there may be another type of employee which will inherit everything and this. Right? But here, if you just saw this one, you won't get that feeling. So what I want to... No.
Yeah, I mean, that's exactly it. So what I'm saying is that if we have one employees table, right, and there's a type, an employee type, it's a toggle in the table itself, right? Depending on how the thing toggles, you inherit differently. Right, you can't have in the employee, have it set to employee type as salary and also have a value in hourly wage. So that column is effectively cut off. It's going to be null for that type of an employee. So, which is the whole reason. It's a way of saying that yes, all of your records in employees, they have name, address, zip code, all that stuff, and then based on it's entirely just an engineering implementation based on the way that a type field is set. Either one of these columns is going to be active. That is to say, the employee is going to sort of inherit and be able to have a value in there, or the other is going to be active. And all I'm trying to make, the only point I'm trying to make is that you can have one of these diagrams which is logically consistent and still implement it with a different number of tables or different structures, right? And I'm just trying to make that point because folks have asked, is there a one-to-one correspondence between the way that these diagrams logically present, the differences in your data types and how you implement this stuff. And I think it's obvious that there isn't. You can implement things in a lot of different ways.
Why would you not then change your ERD to correspond to your implementation?
The question is...
It doesn't correspond to
No, what I'm saying is if I look at the representation like this, right?
This can be a table for
It does not have to be a table for
the question would be in the case that the hourly wage was entered and there was a flag in.
That's the whole point.
There was a flag in one employee table. How you would represent that? How would you represent the constraint visually in this diagram if they're all fields in the table, but some of them are only going to get filled dependent on what the values are in other fields in the same table?
Okay, so what you are saying is that if there was an hourly wage here, then you'll have another. That what is the wage? Because what is?
I think the issue would be like employee type. They're all attributes sitting off that table. You've got employee type now. Hourly wage will depend on
whether it'll be null or some value. So that means you have hourly wage here and a wage here, which will draw a value if this is toggled to true. Then this will it can't have a null value, right? So these are the things that you'll...
How would you represent that? That's the question. How would you represent that in a visual diagram if they're all sitting as attributes of the same box?
So what we're trying to say is that there's a...
How would you represent that constraint? It is a constraint, so the question is how you visually represent it, I think is what you're...
Right, and I'm saying that it makes perfect sense to visually represent it using this kind of little ISA branch, right?
Let me think.
How would for basic engineering reasons, you might want to have the whole thing in one table, right?
But ISA can allow overlap. It doesn't necessarily mean an employee doesn't have both rules.
Right. They're sort of unclear.
This is...
point out that ambiguity in the book. And I would say that the way to represent exactly that point is to, if it's an either or, I would draw them both from the same ISA. And if it's also true, like an employee can also be, birthday pal or something. You could have another line coming off in another ISA box as a way of saying that you can be both, an hourly wage employee. I think that would make that clear.
I'm actually thinking about how would you represent this relationship. Okay, so now we are talking about an attribute having an attribute.
Yes.
Okay, so then this will have to be converted into a object so that it can have an attribute.
Right.
Okay, and then they will have existential relationship between the two. Because if this doesn't exist, this doesn't exist.
So but that's kind of what we have then. I mean, we have...
Yeah, no, I agree. What I'm saying is, I was thinking about how actually to think about, if we move these up there, how would we think of it in representing it? Okay? So now let's come back to your question. In terms of, I'll tell you my bias. My bias is that if my visual representation does not actually tell me how it is being implemented, I would try to avoid it. If in any form, if possible, I would rather try to do this if I'm doing this implementation than actually coming back logically from this again.
Can't you simply draw a line between the two and write along the line what
When you see a square, you want it to be a table?
I'm sorry?
Is it just that when you see a square in one of these diagrams, you want it to be a table?
They will be a table, yes. They will be a table.
Okay, whereas you're looking at it as more of a logical, like a semantics.
Yeah, it's a way...
be a table or it cannot be a table. It's just, it means something.
And it's a way of explaining, like when someone is coming to the thing and sees like, Kevin has built this table that has these two fields, and there's this type field, and half of the fields are null for half the records, and the other field is null for the others, and there's this check constraint in there. Why is that there? It's a way of saying, well, this is a logical, this is a physical implementation of this logical relationship.
Is that part of this notation that entity represents a table? A square represents a table?
Yeah.
Okay, so it...
In that case, we won't be able to...
This is the only correct implementation of this, whatever.
Representation, basically.
But there's obviously some value to
essentially what you're saying, Ravi, is that if we took these two, there's an hourly wage and a wage field, right? They're coming off of those two bottom boxes. And you sort of made the point that if you take them up there and create a relationship between them and a third field, which is toggle, that you're actually just creating new entities. And so what you've essentially said is that, okay, well, if we put this all into one table in this diagram, then we have to sort of move these fields back up here to the top, but because of this logic, they branch back out again into...
That is how I am understanding, because we are talking about trying to set attributes to attributes, right? That is what we are trying to, because
which is exactly what this thing represents. I take issue with the idea that one entity relates to one table directly. I don't think that they make...
One representation, you mean one representation leads to one implementation. That is what you're saying, right? Like, because logically they are coming to the same thing, but you could implement in different ways.
Right, and
okay.
You might implement it in different ways just depending on all sorts of engineering constraints.
Yes,
you break up of your...
Yes, you can. My all I wanted to say, if possible, and if you can represent the ER diagram in the way that you are implementing, it would be better. That's all. If that field actually is being implemented in a different table, then show that in the ER diagram also. That's all. Is that okay?
I can do it that way.
Okay.
This doesn't make sense.
When you have the inheritance diagram, the hourly worker, the part-time worker can't inherit the salary field, right?
No.
So that's not indicated in the diagram, is it?
Which one? Can you say it again?
Yeah. You have the part-time worker, and he's an employee, so he inherits all the attributes of employee, but he can't inherit the salary of the employee, right? So he doesn't inherit everything.
So salary may not be a field of that.
That's a different...
Oh, how would...
No, salary may not be a part of it. It may be a part of some other information. What I want to say is that you will implement this in a way, because it has to inherit, it may inherit social security number, address, and all those things, which are actually common.
Well, I just thought that would be done in the implementation, in the commands, the SQL commands that calculated the salaries and stuff, but not in the DRD diagram.
I'm confused what your question was.
I don't know if it's that. Well, where would you put salary? You'd have to have it. It's got to be in a field with every employee, right?
Well, not for hourly workers. They don't have salary.
Yeah, presumably you'd also have an ISA relationship with the salary workers.
That would be the other branch of the ISA, would be the salary workers.
Salary field. Okay, I'll think about it.
Because you can still have contract workers. That was the thing. There'll be a lot of different types. It is like somebody, the other example that is about like motorboats or something like that, or whatever it is. It's not exhaustive.
You just put the basic stuff in the employee framework and then the salaries for each.
So if you want to implement something where you will have like this, you would have to keep the things which are common here.
Yeah,
right? That's all. Okay. So after this is when you will actually make sure that you have normalized, you don't have data redundancy, and so that is that the next chapter? I think that is the next chapter.
Would those rules knock out just one big table with the different kinds of workers in it?
It may. You'll have to make sure that you do the normalization. Okay. Okay. So now what the other thing that they talk about is what kind of, there is this hourly wage, and then there is the example that they give is the contract worker. Is another type of a employee. And so this guy will have its contract ID here. Okay? Now, what they say is, if you want to actually understand the relationship, you want to check, do these overlap? Can one of this be one of this? Okay, so they don't overlap. Okay, a contract worker is not an hourly wager. Okay, so they don't have an overlapping constraint that is being used. But if you have another type of employee, another one says, so senior employee is somebody who could be a decision maker. That is all his attribute is, or something that a contract worker can come in and actually become a project manager for some time, or have the role of. So it has to have all the attributes of this to be able to be one, like have the same attributes. So then you have overlapping constraints. Okay. It's still, that is why I'm telling you it is very, very subjective. It's really subjective, and because this representation, same thing, there could be another one of regular employee or something. So when you are thinking about these, just think of them that does intuitively it makes sense to you, and that is where it becomes very subjective.
But, so I missed the point. So overlapping constraint is not bad, is it?
I'm sorry?
Overlapping constraints, that's not a bad thing.
Overlapping constraints. It's more of telling you the relationship between two different entities. You are not actually constraining one to be the other, but when you are designing your system, you are allowing that this contract ID actually can have the same. Now that is what is redundancy, if you think of. Why would you have that? But because this guy is a contract worker. So again, it all depends on the situation. It's very subjective. I really do not want to talk about it more, because it's so Can I borrow somebody's book? I actually want to this. Let me see.
But they also make the distinct point that you have this diagram that has 3 different boxes, and that you can translate it either into 3 tables or 2 tables. So I mean, right there they make the point that you don't have to have a one-to-one correspondence between boxes.
You can't.
No. Well, I don't say to redraw the diagram. I say to redraw the diagram. If you want.
Okay, let's put on the gloves.
Yeah, tell me. Exactly. No, that's a valid discussion point.
Important sort of conceptual point.
Yes.
From experience of having designed a million of these things, which is that sometimes the kinds of relationships that you're trying to express here are not captured very well by sort of counting the number of tables. We're trying to sort of look at the table structure and sort of tease out and see exactly what's going on, because you can have all kinds of logic that's either built into the table itself or built into the front end that that sort of draws these kinds of distinctions. So I think that there's a real value in drawing the distinctions out in something like an ER diagram, right, and making it sort of explicitly clear where sets of things in the database overlap and where they don't, regardless of whether they're stored in the same table or stored in different tables.
I agree with that point, but I still okay.
So
it's. I think it is a preference issue. It's a preference issue because when we were writing up the modules that we worked on, for us it was very important that when you are doing it, the person should actually know that which place to look for this attribute. I can go get it. Something. If I put it here and it is actually a part of this column, okay, where would be my first chance to look for it? I'll go into the schema. Where would I look for it?
Well, you'd probably look for an hourly wage table, and
you won't find it. Right.
So then you'd go and look at the employees table.
I agree. No. What I'm saying is, I fully agree. But if this was 10 lines buried deep down, what will you do then? So all I'm saying is, I absolutely agree. I mean, you can represent and actually break it out so that it is much more clear what is being inherited by what. Okay, that is where the overlap is. But I would still personally put it where I'm actually adding it, if I can. That's all.
Yeah, I mean, I guess I'd say if it was 10 lines down, then the value of actually making it explicit and teasing it out becomes even greater, in my opinion. So.
Okay. Okay. Shall we continue? Okay. So let's actually do one example to look at translation. I think that is where the most important thing we want to get at is.
One more question I think is the fact that there are these cross constraints. Does that
cross constraint?
I mean the foreign keys in effect. Well, I'm just trying to figure out, does the kind of the strict inheritance idea really, does it break down at all in this? Like an hourly worker seems to inherit everything from the employee's team. But there are other constraints that kind of go outside that relationship. Then kind of the strict inheritance idea breaks down. Is that kind of...
By inheritance, what you mean is it'll have something like let us think that it has a foreign key that points here, right? So now, what is the next question? Now you tell me.
What if it has a foreign key that points somewhere else, or outside this table entirely?
What would it break down?
There should be able to be multiple inheritance. That would be what that would be. An hourly worker might have is a relationship as an employee and also is a relationship as a union member.
What would...
I guess that doesn't do any damage to this diagram.
Yeah,
you'll just draw another relation. Member of could be another relation, member or something. Does that answer?
It's definitely not strict inheritance and like an object-oriented programming sense, right? You know, because the same employee.
Could be.
Object-oriented, you couldn't have like, you know, an hourly worker and a senior employee both being
Same.
the same literal employee.
Yeah.
Those would be two separate objects, whereas here you can, right?
Can you have entities connected without a relationship between them?
That is what we just talked about. Because now, how are they then related?
I don't know. It would just be a one-to-one man.
Yeah, if you have that, it is like you may have a foreign key in another table.
Yeah.
Yeah.
You can do that in the diagram. You can put the relationship in there, then when you would, if it were one-to-one, you would need a table for it.
Yeah, exactly. Trying to think which example should we take. I think I like this one, in which, okay, let us take this example where you have okay. So let us look at this diagram where there is a relation reports to, and it points now the subordinate is also an employee and the superior is also an employee, a supervisor is also an employee. How would you actually write the table for this? Because you'll have to distinguish. So if there was only a single connective between these two, because there is no conflict, this SSN can be used to construct the primary key for this relation. Okay? But because both of these are being used and they will be included, that is when you will make the primary key in this report. So you will have the same create table reports to, and you'll go in, and then the primary key would actually contain, so you will have superior SSN and subordinate SSN. And you'll have your table created there. Okay, that is one example that was good.
Robbie, how do you handle situations in which you have a relationship between employees, but it's not a relationship in which there's a clear differentiation of roles? You know what I mean? So instead of sort of saying like, you know, so and so is the superior and so is a subordinate, it's more like, you know, employee A and employee B are both friends.
Okay.
And you want to capture that, right? I've always had trouble with that because you sort of have two
peer relationship.
It's a peer-to-peer relationship, and it's sort of like if you say A is a friend of B, right? That doesn't, in your queries, you have to do some sort of trickery to also capture the relationship of B as a friend of A, right? So you have to sort of enter two rows, right? Or you have to do some sort of a union query where you sort of flip the things around. So I was just wondering if there's any sort of neat way to do that.
Okay, let's think. So we want to actually, instead of actually having two rows, if we can somehow represent that relationship with a single row, right? That is, instead of entering two rows, friend of or something like that, and having the same data, I mean, logically it is the same data appearing twice, right?
Within the table, then you can have a table which is friendship rather than friends, which has
map. Basically, you could map relationship map table, where you could say same friendship table where your two columns are who are the two people.
Right, but it's the same problem, though, right? Because if you sort of say, you know, I mean, we have the first field and the second field, right? And we put in, you know, that employee A is a friend of this person, and a friend of that person, a friend of this other person, or whatnot, right? And so you're like, okay, well, show me all the friends of employee A. So you write sort of just a simple query that looks up employee A's ID in the first column.
Yeah, and finds the friends. Okay.
Everything out, right? But then if you want to look for sort of the opposite, show me all of employee B's friends. If you look on the first column, unless you've written everything in twice,
you will miss out.
Right. So I guess what I've done in the past is I've done a union query
Of the two?
Of the two, where I just flip the two columns around, so then I have the whole shebang sort of twice and then select out of that. But it seems really inefficient, and it's just, I don't know, maybe there's no way around it.
And it becomes a little redundant to actually have, for something like this, a mapping table. It's yeah.
Yeah, I mean, it's sort of, but I can't think how else to do it, right? I mean, you sort of have one entity and another entity, and you want to have this relationship. It's a reciprocal relationship, so it becomes kind of redundant.
I'll think about it. We'll see. Most probably somebody might have thought about this before us, and trying to think how else would you do it.
Well, the assumption is that if A is a friend of B, that B is also.
I was thinking, in my case, that most of the people I think of my friends. I can't say how much I pay them.
Okay, so basically what you want to do is, I have another example, but I think what we should do is we should cover more examples in the recitation today on this. Second, I still want to know from you guys as soon as possible if you want the SQL thing. Do you want afternoon off? Do you want tutorials? Or do you...
the answers to the quiz, like actually the other topic,
Okay.
Yeah.
I think that's fine. So we can use the recitation to actually go over the answers for the quiz.
Okay.
Yeah, do the topic.
Yeah.